Hello everyone, and welcome to our video on a library of functions. So I think this one will be a pretty short one. Basically, we're just going to review a collection of common functions that we're going to see a lot, make sure we know the terminology that we use for those functions, and then go from there. So first of all, we're kind of restating a different definition in a slightly different way. Let b be a real fixed number. The function f of x equals b is called a constant function. So what a constant function means is just that the y value is always the same. So if I have, for example, f of x equals 5, okay, again, what is a function? It's a rule that assigns each input to a corresponding output. This rule says, hey, no matter what x value you pick, 1, 2, 3, whatever x value you pick, when you plug that into this function, that input gives you the output of y equals 5. Right? So you just get the same output no matter what, and that's a constant function. All right, definition number 2 here. The function f of x equals x is called the identity function. Okay, so this is just a straight line with slope 1. It's a pretty straightforward function. So when x is 0, we get 0. When x is 1, we get 1. And that's why it's called the identity function. Each input corresponds to the same output, right? And this also equates to being a line that passes through 0, 0 and has slope 1. Right, so each time we increase x by 1, our y value increases by 1. Now, in general, if m and b are real numbers, the function f of x equals mx plus b is called a linear function. So the great thing about this form for linear functions is it makes them very easy to graph. Because we always know that if x is 0, we get b. So that tells us the y-intercept of a linear function is always this value b. So we can graph that. And then what else do we know? We know that when x goes out to 1, then I need to add m times 1 plus b. That means if I go out by 1, I need to go up by m. Well, rise over run tells me that that's my slope, right? So we go out by 1. When x is 1, I'm adding m to the whole value here, right? So I go over by 1. That pushes me up by m. And there's my line. And of course, if I make x 2, that's just going to increase the whole value by m again. And so we just keep going up at that constant rate. So this is a linear function with slope m and y-intercept b. Okay, so we can use that to graph a couple of these things. So let's take a look at this one. Graph y equals 3x plus 2. So the y-intercept is 2. The slope is 3. So if I go over 1, I need to go up 3 more. So I get that point and that point. There's my slope. And this goes to the right and left forever, right? There's no x values that you can't plug in here, and you'll get any possible output value there. So we would say the domain is negative infinity to infinity, and so is the range. And we can do the same thing for this second example here, but this time our y-intercept is negative 1. And our slope is negative 2, so when I go over 1, I actually need to go down 2. So over 1, down 2. That puts us right here. And there's my graph of my line. And again, this is a line, so its domain is negative infinity to infinity, and its range is also. All right, let's move on here to piecewise functions. So typically, I find a lot of students are a little bit rusty with piecewise functions. It's pretty normal. And And I think they can be a little bit confusing if you don't have the right approach. So typically what I find is students have the easiest time with graphing and interpreting piecewise functions if they first graph each of the basic functions separately. So I'll show you what I mean by that. So this example, so first of all, what is the definition of a piecewise function? A function is called piecewise if it assigns different rules for output values for different parts of its domain. So for this example, graph the function f of x equals x squared if x is greater than or equal to 0, and x plus 1 if x is less than 0. So again, a function is just a rule that assigns inputs to outputs. A piecewise function just adds an extra condition that says, hey, first look at what the value of x is. Is it positive in this case or negative? You could have a different restriction here. It doesn't have to just be at 0. But you first look at, hey, where is x located? And then you plug into the appropriate rule based on that. So let's start by graphing it. So I find, again, it's always easier for students if they first graph each function separately. So I'm going to graph the whole function y equals x squared. So remember, that's our quadratic. And when x is 0, we get 0. When x is 1, we get 1. X is 2, we get 4. So forth and so on. So that looks like that. And now I'm going to graph y equals x plus 1. So the y-intercept here is 1. The slope is 1. So I'm going to go over 1, up 1. And then this line looks like this. So now when I want to graph f of x, I just have to take these two graphs and place them in the appropriate domain, right? So let's just read this. This says it's x squared if x is greater than or equal to 0. So that means my breaking point here is at 0. And when x is bigger than or equal to 0, I draw the graph of x squared. So I look at the graph of x squared. So from 0 to the right, that's what I'm going to draw here. And now, for everything left of 0, I'm going to draw the line x plus 1. So that's going to look like this. So now, one thing I want to point out here is that since it says that this is x plus 1 if x is strictly less than 0, we put an open circle here to show where the graph is going, but that it doesn't actually take that value. When x is equal to 0, it actually takes this filled in dot value down here at y equals 0. So that's all there is to graphing piecewise functions. If you just draw your original functions and then break them up into which part of the domain is relevant for which function, they're pretty easy. Okay, so now let's evaluate these two values. So f of negative 2, so it's negative, so I look at the x plus 1 portion. So that's negative 2 plus 1. Which is just negative 1. And now let's look at f of 3. Well, 3 is positive, so that puts it in this portion of the definition, the x squared. So I just put 3 squared, which is 9. All right, and that's it for number 3 here. So now let's take a look at this next one, graph y equals the absolute value of x. So this function, in order to understand how to graph it properly, we really have to understand it as a piecewise function. So the way we properly define the absolute value, so our intuitive understanding is, oh, you make the number positive. A more rigorous understanding is actually that the absolute value describes the distance from 0. So the number negative 3 is a distance of 3 away from 0 on the number line. But one of the proper ways we define this is as a piecewise function, which says that the absolute value of x is x if x was already positive or 0, and negative x if x was negative. That might seem a little weird at first, but let's just see it in action, right? So if I take the absolute value of 3, well, that's just 3. But if I take the absolute value of -2, well, that's -2, which is +2, which is what I would expect to get, right? So that's all this is saying. So now, when we go to graph this thing, we'll just start by graphing the two more basic functions. So y equals x, that's just the identity function, looks like that. Y equals -x also passes through 0, but its slope is negative, so it looks like that. So then when I draw the absolute value of x, the breaking point is at 0 here. So I'm just highlighting 0. And at 0 and to the right of 0, my graph should look like x. And to the left of 0, it should look like y equals -x. Now, I can have a filled in dot here because both of these graphs approach the same value. So I don't have to have like an open dot and a filled in dot, right? They both approach the same value. So I can just put in a filled in dot there. Okay, well that's it for graphing the absolute value of x. Now, let's go ahead and take a look at this list of some common basic functions. So I'm not going to, restate all of this stuff. I'm just putting it on the screen here for you to take a look at for a moment. You can pause the video now. I'll scroll a little bit forward, and then you can see the rest of this. So again, this is just a summary for you to look at some standard functions. These should mostly be review. If you're a little bit unsure about any of these graphs, you might try plugging in some values to take a look at those. Notice something like f of x equals 1 over x is undefined when x is 0. That's why we get this asymptote behavior, right? Because you can't divide by 0. Same thing here for this reciprocal function. So I would suggest taking a little bit of time through those, maybe plug in some x values, get comfortable with the shapes of these graphs, and definitely review these because all of these basic graphs, you want to have a good understanding of what they look like and how they're shaped like, because you may need to use these to graph in some various problems, right? So again, I suggest just look back through these graphs, refresh on the domains, ranges of these, and make sure you're comfortable with them. All right, thank you for watching.